So for the block, get your answer. Have a piece of paper and pen with you. So keep working side by side quickly. So the minimum amount of force that one should apply would come out very similar to the last expression as this. There will be a minus sign here. In the last expression you had a plus sign. So you can work this out, very similar to the last case, shouldn't be difficult. Okay. This time suppose we have an inclined surface theta, and suppose you are applying force F parallel to the plane of the wedge. Now the question is, what should be the minimum amount of force that you should apply in order to pull the block upward? So quickly draw the FBD and get your expression of your minimum force. So we'll start from FBD. This is the block. This is mg downward, this is F, and this is normal reaction perpendicular to the plane. Now, the minimum amount of force you will get when you look at the opposing forces, and we left one force which is friction. So this F has to overcome friction and a component of mg which will be down the inclination. So this F actually has to overcome two forces, friction and mg sine theta. Now when the value of the applied force is just equal to the summation of these two forces, then the block will just start to move, and the F you know is mu times n, and from here you can see that normal reaction will be mg cos theta. So you can see here that the minimum amount of force required will be mu times mg cos theta plus mg sin theta. That is the minimum amount of force that is required for the block to be just start getting pulled upward. Okay, now let you tell me what would be the minimum amount of force required in order to avoid slipping of the block downward. Think about it. The minimum amount of force required to stop slipping of the block on the wedge. Okay, now to stop slipping, suppose it is slipping, then if it is slipping, then it is slipping downward, because mg sin theta must be pulling it downward. Now if it is slipping downward, then the friction force should be acting upward, and if friction force is not able to stop the slipping, then if you're going to apply some external force, then that external force and friction both are going to together try and stop the motion. So friction force will be acting in upward direction if it is slipping, and you come to the rescue and you try to stop slipping. So this time your force and the friction force together will try and stop slipping, and the slipping is caused by mg sin theta, this component of mg. Now mg sin theta should be equal to capital F plus small f. So this you will have a minus sign here, and you'll have a minus sign here. So mg sin theta minus mu mg cos theta is the amount of net force downward. That should be the force applied upward, and that will balance the whole system. That will balance the block and bring it in equilibrium position. So in order to stop it, just stop it by slipping, you have to apply lesser force. And now when you begin to pull it upward, then what would happen? The direction of friction will reverse, because previously when it was slipping, the block was moving down. So the friction force was upward. Now you have stopped slipping. Now if you start to pull it upward and try and pull it upward, then what will happen? The friction force will reverse its direction, and it will oppose the relative motion, because this time if you start to pull it upward, the relative motion is in upward direction, up the plane. So the friction force will act down the plane. Friction force direction changes as per the relative motion. If it is going down, the friction force acting upward. If it is going up, the friction force will be acting downward.